So this is more just manipulating these identities to simplify. I skipped 25 to 29, that section, 25 to 30 section there, because it was the same as basically the same as the ones from before. You're just playing around and matching them up. Essentially, these are basically the same. They're just not giving you any options to make sure it. You're going as far as you can. Like in those other sections, you kind of had a little bit of a guide to say, oh, hey, by the way, you're done. So I'm just going to do a handful of these and then move on to the next section. And, again, the most important thing for you guys to keep in mind when you're doing these is that you're not always going to choose the right way first. I don't always choose the right way first. A lot of times I do these problems out before I do them on the videos, so I don't, make a mistake. But it doesn't mean that I'm doing them all right away. And I do have a little more experience than you guys do, so that also helps. But so here's 32. We're going to take a look at this. Right away I see we got a bunch of signs, and then we got this cosecant. And I believe that's phi, I believe is what the Greek letter is there, but it doesn't really make any difference what it is. So I'm going to change this into 1 over sine right away, just because everything else was in sine. That's kind of why I thought to do that. And now I'm going to distribute, so then sine times 1 over sine is just going to be 1, and then sine times sine is sine squared. Okay, and then this is one of our Pythagorean identities, and so we can say that this is cosine squared. So keep that finger on that page in the book so that you can refer to it until you have them more memorized. So I'm not going to do all of them from this section, but this one looks like another good one to do. So, I'm looking at one of the Pythagorean identities because we have squares. And that middle one says 1 plus tangent squared of u equals secant squared of u. And so I'm not going to mess with the secant. I'm not going to make that 1 over cosine squared right now. So I'm going to distribute that first. And again, that's just from kind of knowing really where I'm trying to go right now. But, if you change that to 1 over cosine squared, that would not be horrible. You would just maybe have to deal with something later. But if we distribute this, we got secant squared of x minus sine squared of x times secant squared of x. And now I am going to change the secant squared here to cosine squared. So then I'm going to leave this one alone. And then I'm going to simplify that. And then I'm going to simplify it one more step. And then that is that middle Pythagorean identity just rearranged. And so then what we're going to say is this is equal to 1. So this whole thing, from the beginning up there is actually just 1. So we'll take a look at 38 and then maybe 42, and that's all I'm going to do from this section, I think. So we have this to start with. Again, anytime you have one of these squareds, you should automatically be thinking of those Pythagorean theorems. And we basically just dealt with this one. Maybe this isn't the greatest one to deal with, but they're all basically the same, right? You're just going to try things out until you get the right combination. But definitely a hint would be if it's a squared one of these trig functions squared, then you should be thinking of the Pythagorean identities. Tangent squared plus 1 is the same as secant squared, so then we really have just secant squared of x, and then you would never really leave it that way, right? Secant, 1 over secant is the same as cosine squared of x. And then I'll do 42. And again, right away when you see this little setup, this is one of those co-function ones. It would be awesome if you memorize all those. Cotangent of pi over 2 minus u is the same as tangent. So then this is really tangent of x times cosine of x. And maybe at first glance that doesn't look like it simplifies anymore, but remember tangent is the same as sine over cosine. And now we're multiplying it by cosine, which is over 1. Cosines cancel, and so we have sine of x. Okay, for this next section, they're telling you that they want you to factor, okay? And so all the factoring rules are the same, and you just got to recognize the different forms, and instead of x squareds and things like that, now we're just going to have secant squareds. When you guys get to calc, especially when you're dealing with limits, it's going to be very useful to be able to quickly identify things that you can factor, and because we'll have to simplify some expressions in order to be able to take the limits, and that's why we're doing these now. All the things like I call it the A times C method. That comes into play. Difference of squares is important. Greatest common factor is important. The sum and difference of cubes is important, and so this one is. All we can see right away is that both of these terms have a secant squared in them. So I'm going to take that out. And when I do that, I'm left with a tangent squared plus 1. Okay, and that tangent squared plus 1 is one of our Pythagorean identities. And so this actually is going to be secant squared of x times tangent squared plus 1 is another secant squared of x. And so then when we multiply those together, we'd have secant to the 4th of x. So let's do 48. Maybe you won't recognize these forms at first glance, but that is one of the challenges that you're going to want to be able to do. Don't ever start canceling unless you have factors, and we do not have factors right now. I guess we kind of do if you could say this is a whole factor, and then this is a whole factor, but these are not the same, and so we do have to manipulate these first. But hopefully you recognize this as the difference of squares. And if you do, this is a pretty easy problem because that would mean that this becomes secant of x plus 1 times secant of x minus 1, right? Difference of squares formula. And now it's over secant of x minus 1. And so now we can cancel this whole secant of x minus 1, and we're left with secant x plus 1. I think it's worth doing many of these because, again, they are going to be important to you. These are going to show up next class for you. And again, you're just trying to recognize these as the forms that you're used to seeing. Usually we don't see it in this order, so I'm going to actually rewrite this one differently. This is, anytime you see a trinomial like this, you should be thinking of some form of the A times C method. At least that's what I call it. And so this is no different really than, like as like a little side thing here. You treat this the same as this. But and you're welcome to change it into that as long as you remember that you got to change it back to, instead of using x's, that we're really using cosine of x's. So you're welcome to do it that way. But really what we're really worried about are the coefficients here. So that's 1 times 1 is 1, factors of 1 that add to give you -2 or -1 and -1. So I'm going to write it out the way I do it. I know a lot of people don't do it this way. That's fine. You guys can make whatever way you want to do it is fine. So I like to break it up this way. Just watch your exponents on these. And I think you would agree that these are the same. This line that I wrote is the same as this line. And again, what I do with these, I say, okay, there's a group and there's a group, and what can come out of both of those. That's a 2 there. Okay, so out of this first one, I can take a cosine squared out, and I'm left with cosine squared of x minus 1. Out of this second group, I'm going to take a -1 out, and I'm going to be left with cosine squared x minus 1. And what's nice about this is that it always works if you do it correctly. And we have this big term and then this big term, and they both have something in common. So I'm going to take that thing that they have in common out front. And so then I would have cosine squared of x minus 1 and cosine squared x minus 1. Okay, and again, so the way that works is the common factor here came out here, and what was left from this term, that, and what was left from this term, that. Okay, and so then I'm going to write it this way. We have the difference of squares twice now. We also have a Pythagorean identity. I don't know if that one works here. I'm going to refer back to that real quick. Can we manipulate that around? Yeah, I don't know if that's going to be what the answer really wants to be. So what I'm going to do is do these as difference of squares, and then I'm going to see what the answer is. I don't know how far they really wanted to go on this, but this one can definitely be cosine of x plus 1, and then cosine of x minus 1. And then we're going to do it again with the second one here, right? It's going to give you the same thing. So cosine of x plus 1 and cosine of x minus 1. And so then that could be written as cosine of x plus 1 squared and cosine of x minus 1 squared. I'm kind of assuming that's what they want. That's what they would be looking for. Oh, nope, that is not. So let's see what else we can do. Okay, so this is a good example of you try it out and that's not what they were looking for. I mean, everything that I did was correct, but in the back of the book they have sine to the 4th. So let's take a look at how maybe they got there. At one point I said that this was a Pythagorean identity, but I went down to this method instead. So let's go back to this step. So let me write that down for you again. So that was cosine squared of x minus 1 and cosine squared of x minus 1. Okay, so we had those two. And so then we have this, I'm going to write down the Pythagorean identity. Okay, and so we can move this thing around. So let's, I'm going to subtract the sine x over. And then I'm going to subtract the 1 over. And so then we have cosine squared minus 1 equals negative sine squared of x. And so then we can substitute that back up here. And so that would be, oops. Right, that would be negative sine squared of x times negative sine squared of x. Two negatives multiplied together give you a positive. And so then we would get sine to the fourth of x, which is what they had in the back of the book. So the other way was fine. This is obviously a little bit more simplified. And I guess it just depends on what you need out of it. So we'll do one more here. I think, again, I think it's worth doing this many of these examples just so you guys kind of get a real refresher on your forms. You know, you're really going to want to be able to factor quickly, even if in these, different than what you're used to here. So here's 52. And in 52 we have 4 terms. And I always think of grouping again. So I'm going to group these first 2 and these last 2 and see what I can take out of both of them. So in this first 2 I can take a whole cosecant squared out, and I'd be left with cosecant of x minus 1. In the second group there, I can take a negative 1 out, and I'll be left with cosecant of x minus 1. And so now we have that same situation as we did in the last problem, where we have 1 term and 2 terms, and they both have the same cosecant of x minus 1 as a factor that we can take out. So I'm going to take that out, cosecant of x minus 1, and we're left with cosecant squared of x minus 1. So, kind of going off of what we saw in that last problem, I'm going to check my Pythagorean identities here. And we have this one, 1 plus cotangent squared of x equals cosecant squared of x. And so then we can see it, you can see if I subtract the 1, then we're having cotangent squared of x equals cosecant squared of x minus 1. And so then we can substitute that in right here. So then we would have cosecant of x minus 1 times cotangent squared of x. So again, very important to be able to factor no matter what your variable is. So please take a look at those.